Hello everyone. In this video we are going to speak about the first derivative test, and it represents one of the main tools and applications of the derivative. Here I have two um, graphs of the functions, two situations prepared, and I will comment, so I will just put A and B. With a little bit of knowledge, you can notice that there is in part A a relative maximum maximum. And that means that if you imagine that this graph represents like a trajectory, that trajectory goes up to a certain point or a certain value, and then it starts going down. So that obviously means that at C there is a relative maximum. And you can see that there is a horizontal tangent, so that means that f prime of C exists, and at f prime of C, so f prime, the first derivative is 0. F of C doesn't need to be 0, so this is f of C. So C, f of C is the relative maximum point. If we look at the part B, we can see the opposite case, but with the same logic. Again, if we imagine that this is like a trajectory, then it goes down, reaches somewhere the point D, and then it goes up. So in this case, we have relative minimum. Now, when we have relative maximum or relative minimum, I will just say here, for relative minimum or maximum, we analyze sign, this is important, sign of the first derivative. This is what we will see now is the first derivative test. Before we go into the details, so just have a look. So we'll just remind ourselves something that we said earlier, that is the famous Fermat's theorem. Okay. The equivalent statement to the Fermat's theorem is that if f has a derivative at point A, but f prime of A is different from 0, then A can't be extremum or relative extremum or any sort of extremum. So this is just a reminder. Therefore, whenever we look at the extremum points we see where because this is essentially the statement about the relationship between extrema and the first derivative. This here is meant first derivative, of course. So what Fermat's theorem teaches us is, I'll just put like in the brackets, there is deep connection between the first derivative and a relative extrema. So I suggest strongly that you reread Fermat's theorem several times, and this note is important so that you understand how we come to later to the development. So even here, going back to this diagrams, so to these graphs, we can see that the function is growing up to a point where there is what? Up to the point where there is horizontal tangent. And here the function is decreasing up to the point where there is again horizontal tangent. And then from there it changes. Okay, so that's even from the graphs actually we can see the importance of the points where the derivative is 0. So we have that connection between the first derivative and relative extrema. If the derivative exists but the derivative is different from 0, then at that point where the derivative is different from 0, there can't be relative extrema. So that is a statement of Fermat's theorem restated.